Hey guys, here we are going through a couple more slightly trickier differentiation from first principles past paper exam questions for AS level maths. Let's do it. And first up, given that f of x is x squared minus 4x add 2, find f of 3 add h. Give your answer in the form h squared add bh add c, where b and c are elements of the integers. Okay, so wherever there is an x, it becomes 3 plus h. So, we are going to get 3 plus h all squared minus 4 times 3 plus h plus 2. So, we are going to get h squared add 6h add 9 minus 12 minus 4h plus 2. So, that gives us h squared. Now we have 6h minus 4h, so that's 2h. Now we have 9 minus 12, which is minus 3, add 2 gives us minus 1. Okay, then for part B, the curve with equation y equals x squared minus 4x add 2 passes through the point P, 3 minus 1, and the point Q, where x is 3 add h. Using differentiation from first principles, find the gradient of the tangent to the curve at point P. So, the gradient then is the derivative of the curve when x is equal to 3. So, we are using differentiation from first principles with x as 3 and 3 plus h. So the gradient is the limit as h tends to 0 of f of 3 plus h minus f of 3 all over h. So, we are going to need to work out, we already have f of 3 plus h, we're going to need f of 3. So that's 3 squared, which is 9, minus 12 add 2. So that is going to give us minus 1. So, f of 3 plus h minus f of 3 all over h is gonna be h squared plus 2h minus 1 minus f of 3. So minus 1. So plus 1. All over h. Now the 1's cancel. So we have h squared add 2h. All over h. Which then becomes h add 2. Now, as h tends to 0, h add 2 tends to 2. So, the gradient is equal to 2. Number 2, Craig is investigating the gradient of chords on the curve y equals x minus x squared. Each chord joins the point 3 minus 6 to the point 3 add h, f of 3 add h. The table shows some of his results. Part A wants us to show how the value of minus 5.1 has been calculated. So we are looking at the gradient being minus 5.1. So, well, to work out the gradient, we know it's f of x at h minus f of x all over h. So he's done minus 6.51 minus 6, so add 6 all over 0.1. And that does indeed give us minus 5.1. Okay, then part B wants us to complete the third row of the table. So, what do we know? We know x is 3, f of x is minus 6, h is 0.01. So x add h is going to be 3.01. Now f of x add h is going to be 3.01 minus 3.01 squared. Now that gives us minus 6.0501. So that goes in here. And then the last one is going to be, so the gradient is minus 6.0501 minus 6, so add 6 all over 0.01. Now that gives us minus 5.01. So that goes in there. And part C wants us to state the limit suggested by Craig's investigations for the chords of the curve as h tends to 0. So all that a limit is a number that a pattern seems to be tending to, getting closer and closer to. So if we look at the gradient, it's gone from minus 6 to minus 5.1 to minus 5.01, so it seems to be getting closer to minus 5. Okay, now for part D, we want to use differentiation from first principles to verify the result in part C is correct. Okay, so we know that f of x is x minus x squared. Now, I'm going to find f of x add h instead of going straight for x being 3. You can do it either way. So, f of x add h is x add h minus x add h all squared. So that's x add h minus x squared minus 2xh minus h squared. Okay, so from that, we now know that f of x add h minus f of x over h is of x add h minus x squared minus 2xh minus h squared. Now it's minus f of x, so it's minus x minus x squared, so add x squared. All over h. Now, we have x minus x, so they cancel. We also have minus x squared add x squared, so they cancel. So we get left with h minus 2xh minus h squared over h. Which is 1 minus 2x minus h. So we then know that the derivative, so df by dx, is the limit as h tends to 0 of 1 minus 2x. Sorry. Of 1 minus 2x minus h. So, as h tends to 0, this tends to 1 minus 2x. Now, to find the gradient at point when x is 3, we sub in x equals 3. So, when x is 3, df by dx is 1 minus 6, which is indeed minus 5. Okay then guys, that's it for this set. Take it easy, take care.